Okay, so figure 8.27, it's on page 151. Okay, it's another cut solid using an oblique plane. So first thing we do all the time, set up the question, x1y or xy line, sorry. XY line, and we have 35 degrees and 45 degrees. Okay, so that's 45 degrees. Okay, for anyone that's struggling to get 35, lightly draw in the crosshairs if you want, and set up your protractor and make sure that it is on exactly 35 degrees. So 10, 20, 30, 35, mark it. Once you have a mark then, you can draw the vertical trace. Okay, so vertical trace, horizontal trace. Okay, I don't think anyone has struggling with setting up the traces at the moment. Okay, so the first thing to do is then use the information to draw the question. So 48 and 66, so measuring 48. And 66. Okay, so lightly draw the lines down. Use construction lines. Keep it neat. Half 66 is 33, you know the apex is on that, and it is 80 off the ground. Mark it, that's going to be our apex right there. Okay, so we call that O. So we can join back this point here, so we know the outside points so far. Okay, so do we need to finish off our hexagonal base pyramid? Okay, hexagonal base has 6 sides. Okay, we know that the long diagonal is 66. So all we need to do is find our internal angles. Okay, so the center point. So we find the center point first. So it's down 24. Okay, so this is our center point. So there's a few different ways of doing it. You can use your 60-30 set square. Okay, the ways some people would find it a lot easier to do it this way. So front through the center is 60-30, or we can swing our radius first. Okay. Okay, so we know this has to be horizontal. Then points should be in line with each other. And this point here should be in line with each other. So still construction, so keep it nice and light. If you find that you went too heavy, okay, use a different color then when you're doing your cut surface to show it off. Okay, so them 2 points are going to be in line with each other. And on the ground, same with these two. Okay, so these 2 points here. I'm going to go straight up from the base to the apex. Okay, so now here comes the labeling again. Make sure we label everything correctly. So we have 1, 2, 3, 4, 5, 6, and the apex. Okay, and then plan. Everything will join back to the apex. Okay, same as in elevation. So if you're struggling to view the 3D object, sketch it out. It will help. Okay, so now we need to do the exact same thing. We need to take an auxiliary. So we're going to come over here again, and we're going to look in here along, everything is going to be looking along the horizontal trace. Okay, so it's at 45, so they set it up nicely for us. We can use our horizontal trace and use the 45 degree set square. Okay, set up your x1, y1 line. Okay, make sure you label everything. Okay, it'll make life so much easier on you. Okay, so we need to do the same thing again. We need to pick a random height, it doesn't matter where, on the vertical trace, because that height will be the same height no matter what view we take in it, we'll find it. Okay, so we're getting the edge view of the vertical trace over here. Okay, so I'll just take this height here. I'll do it with the orange again. Take that height there, call it H. Okay, we look along perpendicular to that. Okay, so here we will step up that distance. You can't just take 35 degrees and put it over here, it doesn't work. We need to get the true inclination of the trace, or the oblique plane. Okay, so that's the question started. What we need to do now is we need to look along here, put an auxiliary of our object up here, and where it passes through, where all our edges pass through the vertical trace, will give us the cut points that we can move back around onto our two plan of elevation views. Okay, so first thing we do is all the points that are on the ground, we can start with them. So we're going to bring up 1. Okay, so that's going to be number 1. We'll bring up 6 then. 6, so take your time, do 1 at a time. 2. Okay, O's going to be up here somewhere. 5. 3. 4. Okay, so we can take the distance then of our height of our apex using our compass. Okay, take it from elevation and put it on the auxiliary elevation. Okay, because the height of the apex won't change no matter what view we look at it from. Okay, so if we're looking in along here, okay, parallel to the HT, we will see the edge 1, 2, 3 and 4. Okay, we will definitely see them, so we can draw them in first. Okay, so we have 5 and 6. They won't be seen though because they're at the back, so we'll just put them in as hidden detail. Okay, so we can see now from 1 to our apex is cut along this point here, 6 to apex here, 2 to apex cut there, 5 to apex cut there. So this literally just gives you an edge view of the plane as it cuts the solid, and it gives you all the points. So what we're going to do is we're going to label all them points for ourselves. Okay, just to make it easier to follow. Okay, so we call this A, B, C, D, E, and F. Okay, so if we have all them points, okay, we know that the endpoints are on the cut surface. Okay, they're where the oblique plane, the cutting plane, will go through each edge of the solid, and it has to be that height off the ground in all elevations. Okay, so we have all the heights there, so we know it has to be the height off the ground in all elevations. So what we can do now is we can bring back all our points. Okay, so I'm going to take 8 for example. So 1 to the apex is intersected at A, it's cut at A. So there's 1 to the apex here. So we're going to bring it back down and we find that that's where A is there. So that's going to be A. Okay, so we can do that for all our points. So we bring down B. So B is where 6 is going to the apex. So there's 6 to the apex. So B comes back down, and where it hits that edge, that's going to be B. Okay, so I'm just going to continue on for them all. C, 2 to the apex there. D, 5 to the apex. E is 3 to the apex, and 4, or F, sorry, is 4 to the apex. Okay, so we have all our points there now. So make sure then we have A, B, C, D, E, and F. Okay, so we have all our points, so we can join them up then in plan. A goes to B. Okay, so heavy them in because they're staying at the solid edges now of the cut edge. Okay, so we can go around now and heavy in everything that's going to be kept in plan really quickly, and then we'll finish off our elevation. Okay, so that's the cut surface there now.